Hello everyone. Today let's solve the problem 746. This one, minimum cost climbing stairs. Right. So min cost climbing stairs. So what the question states here? We are given an array cost. See here, we are given an array cost here, and also this one where cost of I is the cost of stepping on the ith stair. So this one 10 steps, 15th stair actually. This one 20th. This one stair, right? So we are given an array cost where cost of I is the cost of stepping on the ith step. So we can start at step 0 or step 1. So either we can start at step 0 or we can just start at step 1 as well. They have strictly mentioned in the question. And climb either 1 or 2 steps at a time. So we can climb 1 or 2 steps at a time. So this is very important, man. Right. So we can climb either 1 or 2 steps at a time, right? So we have to return the minimum total cost to reach the top of the staircase. So we have to find minimum, right? So minimum total cost basically, right? To reach the top of the staircase. So we have to find, or we have to return the minimum total cost to reach the top of the staircase, right? The output that we need to get here is 15. So let me delete this one entirely. Yeah. Now let's do one thing. Let's discuss the approach for the first one. I'll just consider this one first one directly for the approach rather than going with example one and example two. You can just implement the, same thing for the example two. You can just implement or articulate the same thing for the example two as well, right? So the first step here would be, we will be going with a DP. First thing I want to say you here is we'll be going with the dynamic programming to solve this particular problem, right? So first let's consider the same first example for the approach man. Now, first, let's this one. What do we call? Let's define dp of I here. dp of I, right? So dp of I is the minimum cost to reach the step I, right? So it is the minimum cost to reach the step I. So base case here would be dp of 0, that is equivalent to cost of 0. That is equivalent to the cost of 0, comma. So this one, yeah, this is fine. And dp of 1 here, it will be equivalent to the this one cost of 1, right? So this is the base case actually. Just remember this one, right? So we have defined dp of I as the minimum cost to reach the step by base cases. dp of 0 is equivalent to the cost of 0. Same thing goes with the dp of 1, which is equivalent to the cost 1, right? So while I is greater than or equal to 2, I is greater than or equal to 2, dp of I, we can just write it on this way, man. dp of I equals cost of I, cost I'll just consider C rather than the complete this one, cost of I plus minimum. We have to find the minimum total cost to reach the top of the this one staircase, right? So we can just go with the min of this one. I've opened the parenthesis here. Min of dp of I minus 1, sorry, min of dp of I minus 1 here plus dp of this one, plus we don't have to go with a plus, we have to go with comma here, right? So we are finding the min of dp of I minus 1 and min of dp of I minus 2, right? So this we can just go with this. For I greater than or equal to 2, dp of I is equivalent to the cost of I plus min of dp of I minus 1, comma dp of I minus 2. This one, right? So this is fine, I believe, right? So this is fine. We considered the base case as well as we went with this one when I greater than or equal to 2. Then finally we can reach the top either from the last step or the second last step, right? So min of dp of n minus 1, comma dp of n minus 2, right? So this one in the return statement we have to go with the min of this one. What do we call? dp of so this one n minus 1, comma dp of n minus 2 basically. This is the idea. This is the idea behind how to implement the code, right? So basically finally we reach the top either from the last step or the second last step, nothing but min of dp of n minus 1, comma n minus 2. So this is the idea basically. We have started from here. So this is the whole idea. So let me delete this one. Just give me a second here. Yeah, let's do one thing. Let's consider, or let's try to implement the same thing, the idea for the example one. So we'll start from dp of 0, right? So dp of 0, we have the value 10 here, right? So dp of 0 will go with 10 here, and dp of 1 we will be going with this one, cost of 1, right? So cost of 1, dp of 1 here will be 15, the second element, this one. Right, step 2 is dp of 2 is nothing but we have here this one dp of n. If you remember, what was the formula we went with? Dp of I, sorry, dp of I equals cost of I plus min of dp of I minus 1 comma dp of I minus 2. Here in this case, it is dp of 2. dp of I is nothing but dp of 2, right? So this is fine. 0, 1, 2 we have index basically I'm speaking of. So this one will be dp of 2 equals cost of I. Cost of I is nothing but the 20, right? So cost of I is nothing but 20. 20 plus min of dp of I minus 1 comma dp of I minus 2. dp of I minus 1 is nothing but 15, and dp of I minus 2 is nothing but this one, 30 basically, right? So we will be going with a min of this one, 15 comma 30, right? So what is the minimum of 15, 30? 15, quite obviously, right? So this one will be 20 plus 15, right? So 20 plus 15 will lead to this one, basically. Yeah, 20, min of, we have this one. How did I get 20 here? We are going with a dp of, 1 second, cost of I, right? Cost of I is 20, this is fine, plus min of dp of I minus 1 and dp of I minus 2. dp of I minus 1 is this one, 15, right? So sorry, dp of I minus 1 is 10, sorry, this one, the first one, and dp of I minus 2 is 15, right? So this one, why did I consider here? Just give me a second, man. This one has to be 10 comma 15. So let me go with 10 comma 15 here. This is fine, which is equivalent to 30, right? So see here, 20 plus min of 10 comma 15 is this one, 10, right? So this is 20 plus 10, which will lead to the 30, right? So next, to reach the top of the floor, we have to go with minimum of dp of n minus 1 comma n minus 2, right? So that is nothing but min of dp of 1 comma dp of 2, right? So dp of 1 is 15 and dp of 2 is nothing but 30 here, right? So minimum of 15 and 30 is 15 here, right? So we got the output as 15 as we are going with the minimum. So 15 is the output that we got, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct here. So as we are completely familiar with the approach, let's move on with the complexities part. I insist you to do one thing here. So whatever we have implemented, try to implement or articulate the same thing in the form of this one. Same thing for the example 2, right? So that you understand the problem better, right? So now let's move on with the complexities part. So what will be the time complexity here? So the time complexity would be because of n here. So why it is because of n here, time complexity? So it is because of n because we are iterating through all the steps at once. So the time complexity would lead to because of n. So what will be the space complexity here? The space complexity would lead to because of n as well, because we are making use of the, or we will be making use of the DP array of size n. So space complexity would lead to big of n. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively. So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. First, let's get the number of steps. We'll be making use of the length of the cost everywhere. So let me assign that one to the this one. Some variable or variable named n. So just go with n equals cost dot length, right? So let me initialize the dp array as well. This one, new int of size n. Now initially let me go with dp of 0 equals cost of 0. This is fine. So this is the base case. This is the cost to reach the step 0. Also, let's go with the this one, cost to reach the step 1 as well. So this is the base case, right? So this one will be dp of 1 equals cost of 1. This is fine. The next step would be for loop here. This one for we have to fill the dp array from step 2 to n minus 1, right? So this one will be int equals to 2, as we had discussed this one, same thing in the approach, right? We're just implementing the same thing in the form of code here, I plus plus. So within the for loop, so we have to go with the minimum cost to reach the step I. So this one, what was the formula basically? dp of I equals cost of I, if you remember, cost of I plus min. So we'll be going with the math dot min dp of I minus 1, comma dp of I minus 2. This is fine. Finally, what we'll do, let's go with the minimum cost to reach the top from last or the second last step, right? So I'll just go with return here mat dot min. So this one will be dp of n minus 1, comma dp of n minus 2. This is fine, man. Yep. Let me format the code once and let me hit the run button. So the sample test cases are getting passed. So let me hit the this one, what do you call, submit button very quickly. Hope this works for all the test cases. Let's see. Yeah, it works for all the test cases, man. Yep. So whatever the code that we have written works fine for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.